This video is going to take you through the work solutions for the Chapter 2 progress test on bivariate data. Okay, so multiple choice questions. Our first question here, which of the following is not an example of bivariate data? Looking at these pairs. So A, height and weight. So we've got two variables there. So not fitting our answer. B, severity of injuries from falling off chairs and the number of chair legs. So again, two variables, so that doesn't fit. The heights of two people. There are just heights as one variable, so that's a possible answer. All of the above or none of the above. So we've got a possible answer there in C as not an example of bivariate data. Question 2, we're now given a scatter plot and asked for the R value of that scatter plot. So here we can see we've got a general downward direction to the data. It's not a nice straight line, so it's unlikely to be very strong, but it is definitely something that we can see there's a bit of a negative pattern. So of our options there, 0.5, 0.3, they're both positive values, they wouldn't be appropriate. 0 means we would have a completely random scatter and not be able to sense any direction, so it's not C. And then from the two negative options, D and E, E would indicate a strong relationship, D would indicate a weak. So our best answer there is D. Question 3, a Prep to Year 12 school conducted a survey regarding the ice cream eating behaviours of its students. Every student was asked whether they approved or disapproved or were indifferent to eating ice cream before dinner. The results of the Preps and the Year 12s are displayed in the segmented bar chart below. Then our question is asking us, which of the following statements regarding the bar chart above is correct? So we just have to go through and work out which one is the true statement. So 95% of the Preps were indifferent. So indifferent is this middle colour here. Okay, so we can see on the screen it's the middle blue. And so that would mean this group here, definitely not 95% altogether there. Okay, so not A. B has 70% of Year 12 students disapprove of having an ice cream. So the light blue colour, 70%. And yes, we can see if that's lighting up with 30, then in total we've got 70% there of our Year 12s. While 80% of the Preps approve. So approve is our darkest colour and 80%, yes, we can see that equates to 80% there. So it's most likely that this is our correct statement, but we should always read all 5 statements just to be sure that we haven't misinterpreted. So C, 15% of the Year 12s are indifferent. So looking at our indifferent, we're going between 10 and 30. So that's actually 20%, so not statement C. The percentage of Preps who are indifferent to having ice cream straight before dinner is greater than the percentage of Year 12s. So indifferent, the blue section, we can see we've got about 15% of our Preps, 20% of Year 12, so that's not correct. And finally, E, a greater percentage of Preps disapprove rather than the Year 12s who approve. So Year 12s approve, 10%. Year Preps who disapprove, 5%. So no, it's not greater than. So therefore, we can confidently say B is our most correct answer there. Question 4. From 1976 to 1991, the mandatory use of a seatbelt was introduced across Canada. During this period, the percentage use of seatbelts was found to be correlated positively with the number of cancer diagnoses. This correlation is most likely due to, so note there they're saying correlated, and it's a positive correlation, so we're seeing an increasing relationship there. It's unlikely that seatbelts and cancer diagnosis are directly linked. So we're thinking about whether there is a common response or confounding variables there, or is there absolutely no connection? As soon as you can say that there's maybe one thing that might be a confounding variable, then we have to pick C. So here, what we could say is there's definitely nothing in the middle. So there's not something that percentage of seatbelt users is related to that then directly links on to cancer diagnoses. So we're not seeing that common response. But what we might be able to say is a confounding variable is maybe during that time period there was better public health campaigns. So there was better communication and advertising around public health messages, so using of seatbelts, cancer awareness. And so if there was better public health campaigns and awareness and communication, then we might have seen both of those sets of data have changed and therefore lead to this correlation that we're seeing when we compare the two. So therefore we would say C is our best answer. Not a coincidence. There could potentially be something that links the two. Okay, the following information will be used for both question 5 and question 6. So a study investigating the association between the age of a house and the average area of each floorboard was conducted. The correlation coefficient, so here we're talking about our R value, was found to be 0.72. So describe the association between age and average area of each floorboards in terms of strength, direction, and form. Okay, so 0.72 puts us into the moderate category and it is positive. So if we look here, no, strong, no, strong, no, negative, no, negative. Our only option with positive and moderate, which matches our R value, is E, and therefore we can assume the form is linear. So E is our best answer there. Question 6, complete the sentence. So of what percentage of the variation in the average floorboard cannot be explained by the variation in the age of the house? So this sentence is related to R squared. So the first thing we need to do is take our R value and square that. When we do that, we get approximately 0.52. Now, some people will jump and select B as our answer, but I circled this keyword here, cannot. So we're talking about not the percentage of variation that is explained, 52%, but the other portion. So from 100%, if 52% is explained by the variation in age, then 48% is explained by other factors. So therefore C is our answer. That's a separated question. If you read it quickly and you didn't pick that up and you went to the trouble of realising it was R squared, it's very easy to make that mistake. And they will always put that incorrect assumed answer there as one of the options. So just make sure you're reading the questions carefully. Okay, question 7, we've got some parallel dot plots here. Which of the following sentences comparing the medians in the parallel dot plots above is true? So before we can do that, we need to find the median value, okay? And we need to work out, well, how many data points am I dealing with? So if we count those up, got 4, 7, 9, 10, 14, 15, 16, 17, 20 data points altogether. And there's also 20 in the second dot plot. So that tells us our position of our median will be between the 10th and 11th data point. So beginning at one end, the minimum or the maximum, count in until you're at that point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between the 10th and 11th, my median for before is 5. Again for after, so counting in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, in between the 10th and 11th. So my median here is 4. And so now we can check which is the most correct statement. So A, the median for both is 5, no. The median for after is higher than the median for before, no, it's the other way around. So the median for before and after are 5 and 4 respectively. 5 for before, 4 for after, yes, that's our best answer. Median for both is 4.5, incorrect, and we do have a correct statement, so none of the above is not our option. Question 8. A new cafe opened on the 1st of October. The sales of cafe lattes and cappuccinos for the month of October are shown in the back-to-back stem plot below. At the end of the month, the cafe management has realised that the cafe is understaffed, but they lack the time to train new staff in making both cafe lattes and cappuccinos. Which of the following solutions and their reasons is supported by the data given? So if we have a quick look at the reasons, we will then be able to work out, well, what data do we need to support that? So quickly looking here, they're looking at removing some because they have a lower median or a greater range, or the distributions is skewed. So let's check what the medians are and the range of the values just to see if we can work out whether one of those statements is valid. So going back to our stem plot here, we have 31 points on each side because there's 31 days in October, and you can do a quick count to make sure. So remember the position of your median. So the position of our median, if there's 31, will be the 16th value from your minimum in or your maximum in. So remember, with your stem plot, be really careful that you are counting from the stem each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my median for latte is 29. Cappuccino, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So for the cap, we've got it at 20. So our median is lower for our cappuccinos. Range, if we do a quick calculation of our ranges, your range is your maximum minus your minimum. So for the lattes, 47 minus 8, so we get 39. And for the cappuccinos, we've got 42 minus 1, so 41. So a larger range and a lower median for the cappuccinos compared to the lattes. So if we look at the options here, A, remove cafe lattes from the menu because they are harder to make. The data doesn't tell us anything about how difficult they are. Removing cappuccinos from the menu because they have a lower median number of sales. So checking our medians, yes, that is a possibility. Okay, so that's a possible answer there. C, removing cafe lattes because they have a greater range of sales. Again, if we check, our latte range is actually lower. So that is incorrect information. D, removing cappuccinos from the menu because their distribution of sales is positively skewed. We have a quick look here. I would say we're approximately symmetrical, except for that little bit there. And there's nothing really there in the shape to warrant removing one particular one. So therefore, we can say B is a correct statement. And there's our best statement of the options we have there. Question 9. Australia's top-tier professional gamers were asked to beta test an upcoming release by completing a speed run, i.e. complete as fast as possible, 3 different levels. The time taken in seconds for each level is shown in the parallel box plots below. Which of the following statements is not true? So here, first thing, we have to remember that when we're talking about doing something quickly, it is less time taken. So the faster is going to be at the bottom end of these box plots. So it's important to keep in mind as we read the statements. So let's look at our options here. The fastest 25%, so the fastest 25% is going to be the bottom, the lower quartile of attempts on level 3 were faster than any attempt on level 2. So the lower quartile here in level 3 is faster than any attempt on level 2. That is true. Level 2 displays the smallest interquartile range. So when we look, doing a quick estimation, so we've got approximately 30 as our interquartile range for level 3. For level 2, approximately 20. For level 1, I would say approximately 25. So again, that is a true statement. C, the slowest 75%, so slowest is our upper end, so our upper quartile of attempts on level 2 was slower than the best 50% of attempts on level 1. So upper end here for level 2 is slower than, so higher than the best 50% on level 1. So level 1, best 50% would be that section there. And, whoops, sorry, that was 75%, so it should be that section all the way there. So again, that is true. They look like they might be equal, but that is okay. It fits the criteria. D, the best median time was made on level 2. So remember, the best time is going to be the quickest median. So median level 1 at 90, level 2 at 100, level 3 at 90. So that's not true. That's a false statement, likely to be our answer. And E, none of the above. Well, we can say D is a true statement based on those box plots. The final multiple choice question, number 10. Parallel box plots could be used to investigate the association between location, given as urban, suburban, or rural, and so here we have categorical data. And remember, when you are looking at parallel box plots, like the question above, we want to do a categorical versus a numerical set of data variable. So we need our second variable here to be numerical. Age of marriage given as under 30 equal or greater than 30 is putting it into categories. It's ticking a box. So A is a categorical data set and not appropriate. Favourite cuisine, you would give me a worded answer. So again, categorical, so not B. Number of children, given as 0, 1, 2, or 3 plus. So again, this is split into categories. You would tick an answer, tick a box. So C, categorical, so it's not appropriate. D, annual salary in dollars. That numerical value, so D is our answer. And E, not appropriate because we have D as an option. Now into our extended response. So question 1. A sample of 62 types of mammals was categorised according to 2 variables. The likelihood of attack, given as low, medium or high, and the exposure to attack during sleep, given as low, medium and high. The summary of this data is shown in the following two-way frequency table. So 1A is asking how many of these 62 mammals had both a likelihood of attack likelihood of attack and a high exposure during sleep. So high and high, I have 16 animals or mammals. 1B, of the mammals that had a medium likelihood of attack, what percentage also had a low exposure to attack during sleep? So if we go back to our table, our medium likelihood of attack and a low exposure during sleep. So there's those 2 animals there. When we're looking at that out of the medium, how many had low? So of the medium, we've got 4 in total. So there's 4 animals there. Oh, sorry. Total of 4 animals and 2 were categorised as that. So 50% altogether. 1C. Does the information in the table above support the contention that likelihood of attack is associated with exposure to attack during sleep? Justify your answer by quoting appropriate percentages. So before we can do that, we need to convert our table from raw data into percentages. And remember, when you are converting into percentages, you are looking at the column total. So you're looking at that one single column to convert. So out of the total of 34 in the low column, we're converting that percentage 31 out of 34 multiplied by 100 to get your percentage values. And then we repeat that in our medium column out of 9 and our high column out of a total of 20. Okay, so I've written those percentages in so that we can see them. Our next step is then to pick one particular row and we want to look for change. So remember, we're wanting to see at least 5 percentage point change across our row to justify that there is a relationship there or an association. So we only need to pick one row when we are commenting and providing that justification. So we could either pick low, where we are seeing a small drop from the low to medium, but then a significant drop in the percentage when we get to high. Or we might pick the high row here, where we can see we're going from 3% up to 11 and then up significantly to 80%. So picking one of those rows to justify your statement. And so here's a sample answer. We're saying, yes, it does. The information does support the contention. When the likelihood of attack is high, the exposure to attack during sleep increases from 3% categorised as low to 11% and at medium and 80% at high. And so you're making sure you are giving those 3 percentages and showing or demonstrating the change in those percentages across that one particular row. Question 2. The average monthly income in dollars and the average monthly expenditure in dollars for a group of 15 households have been recorded. The results are displayed in Table 1 and the scatter plot below. For these 15 households, determine the median average monthly income and their mean average monthly expenditure. If we were to read forward, we also know that we're going to need to find the Pearson's R value for this set of data, and then also the coefficient of determination. So it is worth putting this data into our calculator now so that we can quickly calculate that median and mean value and then also be able to find the R and R squared value. So let's put that information into our calculator and then we'll find those particular numbers we need. Okay, so there's a couple of ways we can calculate those two values. We can use our one variable stats and go in and calculate the median for income first, and then do a second one variable stats to calculate the mean of the expenditure. Or we can do it in one go. So in our menu, statistics, stat calculations, two variable stats, we can do it that way. Our X list is our income, Y list expenditure, and then we can see here I have the mean for my X list, so my income. If I keep scrolling down, I get my mean for my Y list, and I also then get my 5-number summary, so my median for my X list for the income, which we need, and if I wanted it, my median for my Y. So it gives me all of that in one go. The other thing it gives me is the R value here. So we're able to get the answer for part 2C that we need later on. So we can do it that way, or as I said, going through and calculating each individual part. So we can see there our median value for income is $5,100 and our mean value for Y, we go back up, $5,216.67. Remember, with your monetary values, unless you're told to do differently, you always round to 2 decimal places there. Okay, and just putting in our 2 values. 2B, write down the response variable. So we already had to decide, and we can see from our scatter plot above that our response variable is expenditure. So just popping that answer in there. Over to 2C, calculate the correlation coefficient, so the R value for the data, giving your answer correct to 3 significant figures. So from our calculator, we're able to get our R value. And we can see from the data that statistics are calculated before, we've got our R value there at 0.96789 and rounded to 3 significant figures. So that would make it 0.968. Okay, so 2D, describe the association between average monthly income and average monthly expenditure in terms of strength, direction, form, and outliers. So we need our statement to contain all four of those things. We know from our R value we have a strong positive relationship. We need to check the scatter plot above on the previous page to check for outliers and form. So we can see, yes, it's of linear form and there are no apparent outliers. So just putting that into our sentence, making sure we're hitting all four of the key things there. And so there's our sentence. 2E, calculate the coefficient of determination. So here we want our R squared value, correct 4 decimal places, and then interpret the coefficient of determination in terms of the variables. At this point, because you have the raw data, you should use your R squared value from your calculator. And we would need to do the different set of calculations to get that value because it's not in the list that we currently have. So from within our calculator, going back into our menu, number 4, statistics, stat calculations, and then number 4, linear regressions. And your X list is your income, your Y list expenditure, and then we're looking for our R squared value here of 0.9368, correct to 4 decimal places. And so taking that value back here, and now completing our interpretation. So the coefficient of determination indicates that we need to take our 93.68. So we don't round that any further. We leave it as that 2 decimal places as a percentage. Of the variation in the average monthly expenditure, so our RV, is explained by the variation in our EV, average monthly income. So being careful to make sure that you've got that statement in the correct order and that you've given that value to the level of accuracy required. And the final question, question 3, we have a scatter plot below showing body density in kilograms per litre plotted against waist measurement in centimetres for 250 men. And so from here, we're asked firstly to the coefficient of determination for this data. So remember, coefficient of determination is our R squared value is 0.6783. Write down the value of the correlation coefficient R and give your answer to 3 decimal places. So when we are asked to find R and we don't have the raw data, we need to use the R squared value and take the square root. But we also need to check the scatter plot and check the direction. Because remember, your R value tells you both strength and direction. And your calculator doesn't know whether the R value is positive or negative. So here, when we're looking at the scatter plot, we can see, yes, we definitely have a negative association there. So when in our calculator, we want to do the negative square root of 0.6783, so that we end up with the correct R value. So from our calculator, we get negative 0.82359, rounding that to 3 decimal places, so negative 0.824. 3B, a spokesman for Men's Health Forum stated that the data shown in the scatter plot indicates that decreasing the waist measurement of males will cause body density to increase. Comment on the validity of this statement. So I've circled that keyword cause. What we're asking here, is it a causal relationship? And what we need to remember is just because there is an association does not mean that a change in the waist measurement will cause body density to increase. There may be other factors involved. It is not a one-to-one relationship in that sense. So we're asking you to say that it is not valid because correlation does not mean a causal relationship exists. And finally, 3C, it is possible that the association between waist measurement and body density can be explained by a common response to a third variable. Give one possible variable which may be considered a common response. So there are many possible answers here. It may be exercise, it may be food consumption or energy consumption, it may be energy expenditure, it may be height, it could be age. There's many different possible common response third variables there. So as long as you're picking one that you feel can have a link to both waste measurement and body density and show that sort of common response outcome, you will be able to successfully get the mark here. And that's the end of our test, our progress test. If there are any further questions, please make sure you check in with your teacher to get some further clarification.